All right, hello everyone. Welcome to week 5. You guys made it. Welcome to the end of the course. Congratulations. I hope to see all your final projects soon. I'm really excited to see what you come up with. But yeah, today we're going to be doing kind of a part 2 of what we did from last week. So we're going to be talking about like different materials and stuff for printing. And then we're going to go into rendering and stuff for your final projects. And then we'll get all of you out of here. So first I'll turn this off. But yeah, so material properties. So 3D printers are capable of printing large amounts of materials these days. Materials are just getting like wider and wider. There's a lot of engineering filaments and other like decorative filaments that's out there. But we're just going to go over a couple of them today. Of course, each material will have its different strengths and weaknesses. So you'll have different drawbacks or advantages for choosing them, along with like difficulty of manufacturing. So we'll just go into that a little bit today. The first one is PLA. PLA is a very common 3D printer filament. It's probably the most common printer filament, and it's mostly because it's very easy to print. There's a wide variety of colors available, and it's just generally good enough for most purposes, especially for like household items that don't see a lot of heat or force. Like if you're printing some like phone stand, a lot of those will be found in like PLA, stuff like that. It's really easy to print. One upside is that it's technically biodegradable, but it has to be under like very special circumstances for that to be true. But some problems is that it doesn't have very high temperature resistance. So if it's under like high heat conditions, then it will tend to melt or warp, which is not always ideal. And it's not always the strongest filament. There's a bunch of additives that people add into PLA to make it stronger. So that also is really nice. People have a bunch of additives and get different mechanical properties, but generally people find just pure PLA to be brittle and not quite the strongest. Another kind of filament is ABS. This kind of plastic is very widely used in the injection molding industry. So Lego bricks and other things like Nerf blasters are all made out of ABS plastic. They're all injection molded, but you can use the same material for 3D printing. One of the advantages is it's a lot stronger than a material like PLA. So it has high strength and durability, which is why injection molding uses it. But some cons is that it's a lot more difficult to print. So it prints at a lot higher temperatures, and it also can warp if you don't have enclosures or other measures in place for your printer. It also produces hazardous fumes. So if you're printing in the same room as an ABS print, you may not have a fun time later down the line. So I don't recommend it. But then again, it requires higher temperature nozzles and higher print temperatures in general. But that also helps it in the end because that means you can use it in higher temperature conditions compared to a filament like PLA. It's pretty cool. It's not as common as it used to be because of other materials, but it's still pretty common. This one's one of my personal favorites, PTG. I find this to be a really nice balance between PLA and ABS, where it's a little bit stronger than PLA in most cases, but it's a lot easier to print than ABS. So PTG is kind of like an offshoot of the kind of plastics you find in water bottles. So those disposable water bottles are made of PET, but PTG is kind of like a different blend of it to make it a little bit easier to print. Again, it prints a little bit higher temperatures compared to PLA, which gives it a little bit more temperature resistant. It tends to be a little bit more flexible after you print it, so it can take a little bit of more impacts. But some of the cons is that it kind of strings a little bit if you are familiar with the term. But when the printer prints, sometimes there's going to be extra filament that will be extruded on accident, and it'll create like little wisps. And you usually don't like those. So it will string a little bit if you don't have your settings dialed in. It scratches a little bit more easily, and it's also very susceptible to moisture. So here in Indiana, the air isn't always the driest, and the filament will actually absorb some of the water. And when that happens, the moisture will be boiled off inside your hot end, and then it'll lead to little print artifacts and like little bubbles. So you don't really like that most of the time. So PTG is one of those filaments that you want to keep in a very dry environment. And if you don't live in a dry environment like here, you can use things like heated chambers or filament dryers to make sure your filament is nice and dry. TPU is also a very cool material. It's very flexible. You can get different kinds of or different amounts of flex, but it's pretty cool because you can print things like living hinges that like bend and stuff after you print it. So it's a really nice material, but you generally have to print a little bit slower, and you have to have like a good printer with dialed in settings, depending on how flexible it is. But yeah, it's pretty cool. Now we're getting into the more like advanced kinds of filaments. These are generally a lot more difficult to print than like a PLA or a PTG. But a nylon is starting to get into the engineering grade, right? So you're getting high strength, high flexibility, high durability, a lot of properties that we all really like, but they're typically more expensive, a little bit more difficult to print because you need higher temperatures, enclosures, and also they're extremely susceptible to moisture, just like PTG. So you can make sure it's a dry environment to print nylon, but it's very strong and it's very cool if you can get nylon working. Other materials, just like nylon, are susceptible to moisture, like polycarbonate. So polycarbonate is super strong. It's basically what they use to make bulletproof glass. So if you like bulletproof stuff, polycarbonate might be the way to go. It's very strong, but again, it's very hard to print. Requires very high print temperatures, enclosures, susceptible to moisture, just like all the other ones. Yeah, so here's like a little graph of all the different filaments. You can see they all have their own strengths and weaknesses. And the cool thing about 3D printing is that you can choose which material that you're using depending on your use case, right? So if you need something really rigid, then you can use something like a polycarbonate. I mean, it's not super common to be able to print that, but you know what I mean. You can choose your material just as if you were choosing like wood or different kinds of metals for your projects. You can use different filaments to get different properties that you're looking for. So yeah, that's just kind of a little summary of all these filaments. There's a bunch of other ones out there that I haven't talked about. They're making new filaments all the time. So yeah, there's a bunch of cool stuff. Here's some resources if you want to 3D print things at Purdue. I'm not sure if all these links still work, but there's several resources around campus. We're in Noy right now, and I'm pretty sure they have a room just upstairs with a bunch of printers, and you can send them stuff and have it printed. BIDC used to have printers. I'm not sure if they still do, but yeah, in general, there's a bunch of resources on campus if you ever want things printed. I have printers at home, and I print things for people, so that's also a resource if you ever want that. I will be printing your final projects if you want them printed. So yeah, I can print things too, or if you know someone, I'm sure they might be totally cool with you printing stuff. But yeah, if you want to print stuff, here's some links. I don't know if they all still work, but yeah, it's here for you. All right, So on to module 5, which is kind of the meat of what we're covering today, is rendering, right? So we've been creating lots of designs, and we finalized a lot of things, but now we want to show these models in a more professional manner, right? So if you see all these like commercials with like phones or computers, you'll notice that they look super clean and super nice, and they like fly across the screen. But those are basically like rendered versions of that product, right? So it's not usually the real one, and they'll just like um, use the computer to render it and create a video. But what we can do on Fusion is we can take our model and we can render a very high quality like photo of our design, right? So we're going to be doing that today, and then ultimately you're going to be doing that for your final project. So yeah, um, oh yeah, final project. I've been over this a couple times. Um, you know, you want 5 design features. Please have it designed with manufacturability in mind, so it makes my life easier to print things, and it also makes your life easier later when you design things, so you can design things that people can actually make. So yeah, please don't do the engineering fountain or like a plane like from other previous assignments. But other than that, you're free to do whatever you like. Please keep it school appropriate. I don't think I need to say that again, but yeah. Um, okay, so back to rendering. So what we're gonna do, we're gonna open Fusion over here. I already kind of got it open, but you can open any project that you want. Maybe like the Lego car is a good one to do because it has appearances and stuff. So I should probably add an appearance here. Okay. So I'm just going to do this gear. This is actually something I'm working on for another class. Let's just say I want a painted blue gear. Okay, so here's our design. So on your screen, it might be the Lego car or something we've done in this class, but make sure you've added appearances. So in this case, I just painted it blue. But we've always been in like this workspace, right? We've been in this solid workspace for the most part, been using like extrudes and sketches, but Fusion has a bunch of other things that you can do. So over here on the top left, you can see that we've been in design. They have generative design, which is pretty cool. And then they have rendering. So we're going to be rendering today. You can see in this little drop down, it has like this really nice rendering of this part that they made. And we're going to do that with our thing today. So your environment will change a little bit. Some buttons will go away and you'll get some new buttons. But now we can see that we can start to render things, right? So first of all, I find this background to be kind of boring. So we can change that by adding things in the background. So up here, we have scene settings, and that'll let us choose different backgrounds for our rendering. So if we click that up here on the top left, I'm going to go over here. I'm going to make sure I change this background from solid color to environment. But if you wanted to render it with the solid color, you could do it. But I'm going to be showing you environments because it's pretty cool. So if I click environment and I click environment library over here, it'll give me a bunch of different options to render like my part in a certain space, a virtual space. So in this case, I just want to choose the plaza because I think it's kind of cool. And now you can see it has like this background of a plaza behind it. You can like rotate it around and you can see it's kind of like the square of some place, right? So this is when you can start moving your part around in space to see where you would think it would fit in your scene. For me, let's say, I don't know, I'm just gonna have this big gear in the middle of the square, right? So let's say this is how I like it. Is everyone following here? Everyone good? Yeah? Okay, cool. So once you find the orientation at which you want your render to render in, you have a couple different options, right? So you can either render it locally on your computer, or because Fusion is cloud-based, you can actually send your part into the cloud and they will render it for you. And this is very nice because generally rendering takes a lot of processing power. And everyone here is CADing on a laptop, so it's not the most powerful machine out there. And depending on how high quality you want your render to be, it can take like several hours to get a really nice rendering, right? But of course, it depends on what you're rendering here. So what we can do is we can outsource the rendering to the cloud, and they'll do it a lot quicker. But here, I'm just going to show the in-canvas render real quick. If you click this button here, you can see it starts from very blurry to a more polished view. This is kind of like a preview of your render, right? You can see like this progress bar kind of showing you like how nice the render is going to be. But it basically takes like exponentially more time to get a nicer render. You can also see that if I start to rotate the part or change the orientation, it will have to re-render it, right? So if I move it around, it'll get really blurry. And then if I let go, it'll slowly get nicer and nicer. So basically what we're going to do is we're going to send our file to the cloud, and then they're going to do it for us. And it's nice because Purdue students get this for free. So I'm just going to stop the in-canvas render over here. I'm going to click render, this little teapot, and then we can kind of choose our different parameters. So over here, we want to make sure that we're choosing a cloud render, and then we can set it to final. And you see, because we have the education license, which I hope you all have, you can have like unlimited renders, which is super cool. But you can see with the final render, it's going to be very high quality, and it's only going to take like 20 minutes. So once you find the orientation that you like, you can just press render. It'll like save your document, and then it'll send it out to the cloud over here on the bottom left. And then in a little bit, the render will come back and we'll have our render. So yeah, it's pretty straightforward, not too bad. Does anyone have any questions? Did they miss anything here? No? Alright, cool. But yeah, that's rendering. So what you're going to be doing, there's an assignment for like the render practice. So you're going to want to render whatever you're rendering right now. And then you can upload the photo of the render when you get it to the Google form. And then you'll be doing the same thing for your final project. And yeah, that's basically it. There is a couple resources that I'm going to find for you real quick. But it'll basically allow you to choose other scenes for your projects, and you'll get extra credit if you use one of those scenes. So there's some scenes that you can like download for free on the internet, and then your background will be different, and it'll be cool. So yeah, if you want extra credit, I'll send a link out later, and you can find those scenes. And yeah, that's basically it for rendering. Does anyone have any questions about this? No? Awesome. Okay. But yeah, that's basically it for today. So it's just teaching you rendering. I'm just going to hang out for a little bit. So if you have any questions about your final project, or if you need any help for anything in this class, I'm just going to hang out and be here for a while. But yeah, other than that, if you're finished, you're feel free to leave. Thank you so much for the past 5 weeks. You all have been amazing, and I look forward to seeing your final projects. Yeah, thank you. Wow, that was so quick.